Today, we are going to look at a very interesting topic in physics, which is the topic is elasticity of solid. All right? It is also described as elastic properties of solid materials in some of the physics textbook. Okay? Now, what is elasticity? Elasticity is the ability of a solid material to go back to its position after being applied by force. Okay? This is the ability of a material to go back to its position after being stretched. All right? Then when you stretch a material, you have applied force. All right? You cannot stretch without applying a force. Do you understand? Remember, force is caused by either push or pull. Do you understand? Force can be caused either you push or you pull. Push means to push it to make it to move away from you. To make something to move away from you is pushing. When you drag it to yourself, that is pulling. Do you understand? All right. So elasticity here of a solid material is the ability of that solid material to go back to its position after being stretched. All right? Or after being acted upon by external force. All right? For example, your skin. Your skin is very, very elastic. The ear and the skin is very, very elastic. All right? Just look at my ear. I push it, right, to move to some extent. Then if I leave it now, it will still go back to its position. That is what we mean by elasticity of solid material. Okay? All right? That is the ability of a material to go back to its position after acted upon by external force. All right? Then, in the course of this study, we have a law in physics that guides us to understand the elastic property of solid. And the law is Hooke's law. Hooke's law. What did the law state? The Hooke's law states that provided that the elasticity of an elastic material is not exceeded, the extension of that material is directly proportional to applied force or load. All right? Provided that the elasticity of an elastic material is not exceeded, the extension of that material. Extension comes after the force has been applied and removed. All right? That extension is directly proportional to the applied force or load. That applied force here is the external force. All right? Which acts upon the elastic material. Do you understand? So that means when a force acts on a solid material, when you remove the force, provided that the elastic limit is not exceeded, it has the ability to go back to its position. That is the elasticity. But there is going to be an extension. Now, this extension we obtain increases as the force that acts on that elastic material increases. That is to say, increase in applied force will result to increase in the rate of its extension. All right? So let's look at the Hooke's law. Okay? Provided that the elasticity of an elastic material is not exceeded. Okay? The extension of the material is directly proportional to applied force or load. That is what Hooke's law is all about. Look at the law. That the applied force is directly proportional to what? Extension. As the force is increased, extension will also increase. Do you understand? Let's look at a spiral spring, for example. Here is a spiral spring. Here is another spiral spring. All right? If you extend this by applying force on it, either by dragging it or by having an object of a given mass on this spring, all right, it's going to do what? Increase in length. All right? The actual length before you apply the force is known as the LO1. That is your LO1, which means length 1. Now, when you now apply a force to drag it to move to some certain extent, all right, after a while, the force will be removed. When you remove the force, it's going to increase to some extent, all right? The length will no longer be at the exact position. There's going to be slight increase in length as a result of applying the force. Do you understand? Now, that shows that this increase in length is known as the extension, all right? And the final length obtained after you must have removed the force is known as your LU2. That length is known as the LU2. Now, how do we now obtain the extension now? You obtain extension. Extension is equal to LU2 minus LU1. That is length 2 minus LU1. That is length 1. We give you the extension. Do you understand? Now, imagine these two springs here are of the same length. All right? The same length. You now increase the length by applying a force. Let's say a force of 50 Newton. Then you increase this length here by applying a force of 1000 Newton. Do you understand? When you must have removed these two forces from these two different spiral springs, okay, you will notice that the extension of this one will be more far or bigger than the extension of this one. You understand? That the extension of the spiral spring 2 will be much more bigger than the extension of the spiral spring 1. That is what the law is telling us. All right? Increase in the applied force will result to corresponding increase in the extension. Do you understand? Okay, now here, force is equal to, when you put the sign of proportionality, you now introduce the constant. The constant here is used as letter K, then extension. All right, where F is equal to applied force, K is equal to constant, E is equal to extension. Now, how do we obtain extension? Extension is equal to length 2 minus length 1. All right? In other words, extension is equal to LU2 minus LU1. Do you understand? Now, there are so many properties we are going to study in this topic. All right? There are so many terminology we are going to look into. Number one is stress. Number one is stress. Number two is strain. Number three is Young modulus. Young modulus. All right? Now, what is stress? Stress is the ratio of force acting on the material to the cross-sectional area of the material. All right? Stress is the ratio, right? That is, stress is equal to force over area. Do you understand? Stress is equal to force over area. Now we all know that area is equals to pi r square. All right? On that case, stress can also be equal to, let me write it here. It can also be equal to force over area. This is equal to area over pi r square. This formula and this formula is still the same. I don't know if you understand. Okay, you understood, right? All right. Now, let's look at strain. Strain here on the board is the ratio of change in length of the material is the ratio of change in length of the material, which is also known as extension. Change in length is known as extension. To the original length. To the original length. All right? So here, strain is equal to change in length, which is equal to extension, all over original length. All right? Strain is the ratio of change in length of the material. The change in length of the material is also known as extension, right? Then to the original length of the material. You understand? Then strain equal to change in length over original length. Okay? It's time to wipe here. Now, strain is equal to extension over original length. That is original length. You can also write like this. Strain is equals to extension over length. But keep in mind that this length here is the original length. I hope you understand. Now, the next we are going to look here is Young's modulus. Young's modulus. Young's modulus here is the ratio of stress to strain. Okay? Young's modulus is the ratio of stress to strain. Now, Young's modulus here is represented with this symbol. All right? So here you can say that Young's modulus is equal to stress all over strain, because it's the ratio of stress to strain. That's why the formula is like this. This represents the Young's modulus. Young's modulus is equal to stress over strain. That is the same as saying is the ratio of stress to strain of the material. Now, this is going to give us What is the formula for stress? Stress is force over area. All right? Force over area. That is the formula for stress. All over strain is extension over length. Here, extension over length. I hope you are following. The length, remember, is original length, right? Now, Young's modulus is equal to, remove this, just write it like this. Force over area over all over extension over length is the same as saying that force over area, this ratio here is equal to divisions. I hope you understand. This is division. Now divide by extension over length. Do you understand? Now the formula can also be force over area. You can change this to multiplication. Are you following now? Then when you change this to multiplication, this will go upside down. You have here length over extension, and that is equal to FL over AE. F is force, L is original length, A is area, then E is extension. Then this can also be equal to FL over the area here is pi r squared, right? This alone is for area. Pi r squared multiplied by extension. This can also be the formula for Young's modulus. Okay? So we are going to stop here today. Stay tuned for the next video. We are going to solve some calculations. JAMB, WAEC, GCE, NABTEB, exam questions that relate to the topic on the whiteboard, elasticity of solid. Please don't forget to subscribe to the YouTube channels, all right? More videos are going to come on, all right? Thank you, and God bless you.